It's water with oil in it. I can totally remember. You should have told me.
There's no oil in it.
Okay, I want you to just shake it up just a little bit. And tell me what you see, Ruben.
Bubbles.
Bubbles.
Blue.
Okay, Christina, I want you to go up there with Ruben and help him elaborate.
Yes.
So you're going to be, Ruben, all you're going to do is you're just going to show it off, and she's going to be kind of the spokesperson. Just think about it as an
The price
infomercial.
is right.
Yes.
There you go.
Alright, it's water with oil in it. And you put food coloring in it, and that's what makes it the color. And then you put it in a water bottle, and that's it.
Cool, and if you kind of put it into the light, kind of lay it down into the light, and I think Ruben
You probably shook it up too much.
really shook that up.
Oh, there's glitter in
There's
it.
glitter in it.
Whoa!
Did you put glitter in it?
I didn't put glitter in it.
There's glitter.
I don't do glitter.
Oh
Someone else did it.
Too serious. It looks like sand. Did you put, is there sand in there?
Some student made it.
Oh. Did you just tell me this? Well, that's different. I'm just told me.
Alright, so what you guys have there is basically, Ruben, go ahead and hold it up again, but this time just hold it up. I want you to hold it. Tell me what you see what's happening. After about 5 minutes, you shook it up real hard. What's going to happen after about 5 minutes?
The water's going to go down to the ground.
Why is that?
The oil's white.
Okay, so this is, you guys can make your own little lava lamp. The cool thing about this is the deal, this is what you need to do. This is not going to be the experiment for next week, but the next week. Because we're doing something even better next week. It has to do with Halloween. What you guys need to do is, I need you guys to bring a water bottle. Some of you guys already brought it, so I have yours. So I need you guys to all bring a water bottle, just this size. The smaller, the better. So if you can get one of those half-size water bottles, that'd be even better.
Pint?
Yeah, if you get the pint. So, I need you guys to get a clear water bottle. You're going to write your name at the top of it and a permanent marker. Also, I need you guys to bring vegetable oil. You're going to bring your own vegetable oil. What you can do is, you can buy a jug and split it with a friend. Just buy a big old jug. It costs like maybe like $3, $4. Grab a friend and split it with them. So you guys need to bring some vegetable
Put it
oil.
in like, how about if we have like, not cool, I'm sorry, do you have and Ellie are better friends?
Yeah, just bring the whole jug. Just bring the
Or
whole
like
jug.
this, and how much do we need this?
You're going to need a decent amount because we're going to do a couple of different things with that vegetable oil. So just buy a big old jug. I mean, if you can get a small jug, I mean, that's fine too. Just get some vegetable oil. So just get some vegetable oil. So it'll be kind of cool. You said what? Vegetable oil? Because vegetable oil is healthy for you. And you're going to be drinking this.
Swag.
No, we're not.
Yes, you are. Sweet. All right. Every single one of y'all are going to like vegetable oil because you're going to learn to love it. I'm just kidding. No, I mean, it's vegetable oil because it's an oil. So let's get vegetable oil.
Can we get baby oil? It smells so good. Oh, yes. Can you get baby oil?
Baby oil?
Yeah.
You know what? Let me do some research and let me just see what will work best. Because we haven't done baby oil yet, so let me do some research and get back to you guys on that.
Your
So what I want you
grandma's
to do is just go ahead and get a clear water bottle and get some vegetable oil. So what? Yeah, get the little one. Get the little one too if you want to. This size is perfect too. If you want to get the little one, that's good too. Either one's fine. And basically this kid, whoever did this one, he kind of messed with the concentrations. And it just kind of, I don't know, I think he put a little bit too much. Put a little bit too much in there. But of course, once you just let it settle for a little bit, it's going to balance out. But I'm kind of looking for larger lava lamp type bubbles. And if you guys put in some what you call it? If you guys put in the, what's the word? The thing that bubbles, Alka-Seltzer. You guys put in some Alka-Seltzer and close it in there. It'll be kind of cool because the Alka-Seltzer, it flows to the bottom, then it starts bubbling, and then it's actually going to shoot up and make bubbles, kind of just like a lava lamp. And then when you put this, you guys can actually put this up in your room. Put one of those like little lights that kind of come under it. It'll look real cool. So it's kind of like your homemade lava lamp. That's pretty cool. But next week we're doing something a little bit different. It's going to be a surprise. I'm not going to tell you guys what we're going to be doing. But what we're going to be doing next week is kind of like, it kind of has a cool theme to it. Like if you guys plan on doing like a little costume party, something like that, what we're going to be doing next week is something that you can actually use for your little costume party. Since it's October, you guys want to do like a little party. Huh? A mask? Can't give you any clues, but be ready for that. So, also going back to my thing about school spirit, remember, so this Friday, if you guys come dressed up, showing Seguin's spirit, you don't have to do essay number 9. Pretty good deal. Remember, this is the last mandatory essay for this third 6 weeks. Next week, you guys can start using your tickets. Question, Christina.
I was gonna ask what like, you know, real lava lamps, what's the stuff that's in there?
The stuff, it's not, I mean, it's not, it's just, it's like a mixture of things. Like, for example, like they're gonna have, there is oil in it, but they use some sort of polymer. So basically you're gonna have like, it's oil mixed with a polymer. You guys don't know what a polymer is yet, but we're gonna get into that. So you will know what a polymer is. But just think of it as being oil for right now with some kind of, think about it, just think of a polymer as something that's just kind of moldable and kind of sticky and gooey. And we'll get into that later on. So you'll actually know what makes up a lava lamp. So remember, this Friday I'm looking for school spirit. I'm not looking for you guys to put like an S on your face. I'm looking for you guys to kind of go all out. Like, you know, Jared's going to make his own t-shirt that says I love Seguin on it. With one of those white shirts. I want you guys to kind of... Yeah, that'll work. If you get a white t-shirt that says I love Seguin, maybe make bubble letters.
Can I bring a radio and play music?
That says I love Seguin?
Yeah.
Yeah, if it says I love Seguin. If it has you rapping like a theme song for Seguin, that'd be even better. If some of y'all can make a Seguin rap theme song that says, talks about how much you love Seguin. Yo mama, I love Seguin. Hey mama, I love Seguin. That's all you have to rap about.
Yeah, you're good at rapping. Y'all rap something.
Yeah, so fine, Aristotle, we're looking for the next, I want you guys to drop a single here this Friday about I love Seguin.
My album don't go aluminum.
It's going to go aluminum, I like that. Not platinum, it's going to go aluminum, another level. So, just be sure that you guys show some school spirit and get that knocked out. I also said the same thing with, are you guys dressed up as superheroes tomorrow? Who's dressed up as a superhero?
Christina, I have a cape and everything.
What superhero are you dressed up as?
Every single one. No,
Every single
Superman.
one. Super Christina? Nice. What's your superpower?
Huh?
What's your power?
Being amazing.
Being amazing? I like that. Very good. Okay, so I want you guys to go ahead and take a look at Chemistry Quiz 25. Look at this front over here. I want you guys to. That's the front. That's the front. Oh!
Y'all too loud.
Okay, so number 1 says, which chemist conducted the cathode ray tube experiment? This is going to be a tax question. So if you can just get this down and memorize this, or just at least by you doing this right now, somewhere it'll stick in your mind, so when you come to the tax test, it's just going to click for you. It says, which chemist conducted the cathode ray tube experiment? It's J.J. Thomson. I'm going to write his name on the board. J.J. Thomson. J.J. Thomson is the guy that conducted the cathode ray tube experiment. Okay, J.J. Thomson. So, don't talk. With J.J. Thomson, he did the cathode ray tube. You guys should know what a cathode ray tube looks like. The cathode ray tube, it looks like a, what did I just say? Okay, cathode ray tube is going to be a glass encased tube that looks kind of like this. You have a tube and you got wires coming up on one side and the other side. What it did is it just shot an electric current and lit up the gas particles. So we're actually doing an experiment with that. Not this class or next week or probably about a month or two. We're going to actually be doing our own experiment where we take a glass encased gas. So it's just a glass little tube with gas inside, gas particles. You're going to have these gas particles. You can't see gas particles, but you know it's there. We're going to send an electric current through it. It's actually going to light up those gas particles. It causes the gas particles to vibrate to light up, and that's how you guys have neon signs. You guys take a look at neon signs. All a neon sign is to say you have the letter N. It's just a glass N with gas inside of it, and they run a charge through it, and it lights up the gas inside. Over here. Where we use that to light up a light bulb or something like that? No, not in this class. You do that in chemistry and physics. So that's going to be more of a physics thing, because you're talking about conductors and just open circuits, closed circuits. Okay, so. Okay, number 1 is J.J. Thomson. Know that he did the cathode ray tube experiment. Number 2, illustrate what a cathode ray tube looks like. Just draw that. You're good. Illustrate what that looks like. Okay, number 3. How many protons, electrons, and neutrons are in an element with an atomic number of 22 and an atomic mass of 35? So, why don't you guys go ahead and give me the answer. Just someone tell me that answer. How many protons are there? Number 3, there's 22. There's 22 protons, that means there's how many electrons? 22, very good. And how many neutrons would there be? 13, because you take 35 minus 22 means 13. Very good, Rodrigo. Okay, number 4. Number 4. It says, do periods on the periodic table go horizontal or vertical? Christina, what was your strategy?
Period, your mouth goes this way, groove, your mouth goes this way.
It goes vertical. I've actually been telling other students that too. So I think I'm really doing that. This is a really good idea.
Oh, you weren't here.
Yeah, so basically, the way it works is if you say groups, your lips are kind of like a vertical shape. If you say periods, you're kind of smiling. So periods go horizontal. So periods go horizontal, period. Groups, vertical. Okay, so number 6 says, how many groups are there on the periodic table? How many groups are on the periodic table?
18.
There's 18. There's 18 groups. 18 groups. 18 groups. Okay, how many periods on the periodic table? 7. Very good. Very good. 7 periods.
That's your answer.
Wait, what was you saying?
7 periods, 18 groups. There's 7 periods. Let's think about school. Actually, you guys have 8 periods, but I have to teach 7 periods. So, because I got 7 classes I got to teach. Okay, turn to the back. This is significant figures. So, with significant figures,
Oh, it's the one that...
these aren't ever going away. This is present and absent.
Oh, yeah.
Significance of the U.S. Atlantic, Pacific, Atlantic. That's significant figures. Once you guys knock that out, I see most of y'all got it knocked out. I'm going to come out and check if you guys did. So go ahead and knock out significant figures. Give you guys about 4 minutes.
Yeah, it is.
Oh, that's cool. Aubrey. Cool. So it's Aubrey 12. Very lucky number.
Yes. And it was how old I was when I died.
Okay, you guys about 3 minutes to knock these significant figures out. You guys should have this ingrained in your brain. Should be second nature. Okay, so remember, significant figures aren't ever going to go away. Scientific notation never goes away. Dimensional analysis never goes away. And now your periodic table, your new best friend, he's never going to go away either. So. I'm just going to come by and check who's got it, who doesn't got it. I'm going to make a note in my notebook so I can keep track. Because I'm going to hammer you guys on top of y'all for this. Okay, most of y'all have got this. I don't think I have to check if the thing's good. I don't have to check it.
No, it's not. It's about like something 106.
Yeah, that's big.
It's the font one, yeah.
You
You're doing scientific notation, but it's significant figures. So you're doing the significance of the U.S. Present, Atlantic, Pacific. So you did that correct, but we're looking for
Oh my God.
significant figures.
I did all that work.
But you got good practice. So you should be able to do that 16, 17, 18, 19, 20, and 21 down.
So there's house, the gone,